there's something else about a function I want to show you. Let's say you've got a function here, f of x equals this here. The inverse of this function here is given by this. Okay, so if you put the number 8 into this function, it would do its blah 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 and spit out the number 10. And then if you put the number 10 into the inverse, it will basically work backwards, blah blah blah, to spit out what you originally put in, which was the 8. Okay, and the same goes with, let's say, another number, 6. If you put 6 into here, it would do its job and then spit out the number 7. And when it comes to the inverse, if you take this 7 here and then put it into the inverse, it will blah 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 do its job and it will spit out the number 6, which was the original here. So currently we've got a function here. Hang on. Currently this is our function here. So this is our f of x here. It's the same thing. This thing here is exactly the same as this here. And the inverse, suppose you didn't know the inverse here. Okay, so you start out with a function here, and you can always work backwards to find out the inverse. Let's say this is our function here. Work out the inverse. So let's say let y equals f of x. So you basically replace this with a y. Okay, so here we've got y here. To find the inverse, make x a subject. So blah 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 here. Work all the way through here, so it gives you will get to this stage here. So this stage here, you can replace the y with the x. So basically f of x here. Well, I've done several videos on this. So when you get to this stage here, you can get to the inverse. So basically this is our inverse here. So given this function here, the inverse is this. Okay, but here's the thing. Hang on, let me get rid of this. Here's the thing. What I want to show you is that if you put this whole thing here into this x here, you're gonna what I'm trying to say here. Hang on. If you have this here, f of the inverse of x here, that equals x. So what I'm trying to say is that if you put this into the x here, then do all your cancellations, and it will give you x. Okay, so for example, what I'm trying to show you is this: if you put the inverse function into the function itself, overall it will be x. So let's try and put it to the test. So now we are going to apply this f. And then, so we're going to put the inverse within the function here. So we are going to put this into this x here. Okay, so this will be, hang on, this will be, it's going to be messy. That's what it is. It's going to be 3 here. So remember, we are putting this whole fraction into the x here. Okay, so it's going to be 3 times 2x plus 4 over 3. Okay, and then you take away your 4 here, and then don't forget you've got a 2 here. What I'm trying to say is that when you have this here, the whole thing here should equal x. So hang on, if you have this here, f, put the inverse into the function here. After you tidying all this up, it should equal x. Okay, so let's just try and tidy up now. So this here, so at the moment you've got a 3 multiplying a fraction, so it gets multiplied to the top. But the thing is, you've got to visualize that this here is a bubble, because you've got a plus in between. So visualize this as a bubble here. So it actually becomes this, hang on, 2 minus 4 over here. So it gets multiplied to the top. So it's going to be this. Remember, it's going to be this times this, and then this times this here, because this exists in a bubble here. Okay, so it's going to be 6x plus 12, and then over 3 here. Okay, let's merge these two together into one fraction, and then we can then easily divide by 2, because at the moment it's quite ugly at the moment. So merge these two together, so it becomes this. It will become this. Hang on. it will become this 6x plus 12 over 3, and then turn the 4 into a fraction, and then multiply top and bottom here by 3. Okay, so hang on. So this here will be 12. Oops, hang on, 12. This here will be 3. So basically, the two denominators are the same now. So the two denominators here and here, they're the same. So we can merge them together. So this then becomes, bear with me. This then becomes, it becomes this. So we've got 6x plus 12 minus 12 over 3, and that divided by 2 here. So let's merge these two together here. Okay, so well, they're going to kill off each other. Plus 12 minus 12, so they're going to kill off each other here. So this will be this 6x over 3, and then over 2. Okay, over 2 here, like this. Well, there are several ways of doing this, but I'm just going to do it this way. I'm going to visualize it like this, divide by 2. Okay, well, I'm sure you can just see this here is 2x, but let's just do it this way. So when you divide a fraction, it gets multiplied to the bottom. So this will be 6x over 6, and then that becomes x. So ta-da, because here, yeah. So this here is what, yeah. So when you put this into this thing here, it will give you x. So going back to here, hang on. Going back to here, given f of x is this, and the inverse is this here. If you put this into here, okay, it will. So if you have this here, f of x here. Sorry, hang on. Let me start again. If you have f of, well, if you put the inverse into the original function, it will equal x. So if you put this into here, it will overall give you this. And here's the thing: if you put this into here, it will also be x. So if you do this here, hang on, the inverse on the outside here, but then put f of x into the inverse here, it will also be x. And if you don't believe me, you can try it for yourself. If you put this into here, it will also give you x. Okay, or if you put this into here, overall it will give you x. So my point is that f of this here equals x, and also this here also equals x. So just bear that in mind here. Okay, so yeah.